was necessary to make this a genuine theory of unified theory of weak electromagnetic interactions. But he didn't think this was too important either because there were some other problems that he couldn't solve. Eventually, the other problems got solved. The theory fit together. The experiments were done. Everybody realized that this crazy theory that Schwinger had originally suggested and we had developed made sense. And so he and I and a Pakistani gentleman, Abdus Salam, shared the Nobel Prize in 1979 for the development of that theory. All the rest is history, and that's the story of my life up to 1979. I was, just to fill in the steps, so after Copenhagen, 2 years in Copenhagen under the aegis of the National Science Foundation Fellowship, paying the glorious sum of $3,000 a year, from which I saved up enough to buy a TR-3 Triumph, which I brought back to California because my first job in America was to be a postdoc at Caltech. I liked it there. It was very exciting. My second mentor after Schwinger was a man named Murray Gell-Mann, who was at Caltech. I spent 1 year there because there was no chance of getting a professorship there. I got a professorship at Stanford, assistant professor. I spent one glorious year at Stanford University. After half the year had passed, I said to the boss, is there any chance in the future that I would get tenure here? And he said, no chance at all, because they hire only from outside in those days. In fact, the time I was there, they fired 5 people, all of whom went on to win Nobel Prizes. Stanford at the time was not, well, they didn't know what they were doing. So I went to Berkeley, the University of California, a much more sensible place. Spent a few years there until I got the call to come back to Harvard. I then came back to Harvard in 1966, stayed there until the year 2000. I got enough of Harvard by then, so I moved to BU, which had the dramatic advantage for me that I could walk to work. And that's one of the several reasons I went to BU. And that's it. That's my story. I want to now answer questions. So, not from you. You've already given me the questions. We'll get to new questions. Old questions come first. These are the ones you sent to me. I'll try to answer them all. 42 questions. That's why my talk is so short. The first question is, how old were you when you first encountered selenium halide? Well, that's from Sam. Sam, are you here? Sam B?
Right here.
Yeah, okay, good. Well, you obviously read my biography. I'm being attacked. What's up?
No.
Okay. So when I applied for the Westinghouse Science Talent Search, which was the predecessor to the Intel competition, you have to have good grades, you have to take an exam, you have to have a project. My project had to do with selenium. Why did it have to do with selenium? Because I knew about the periodic table. I knew that selenium is under sulfur, has chemical properties similar to sulfur. So my project was to see if I could grow hydroponically tomato plants in which there was no sulfur. The sulfur had been replaced by selenium. Could the tomatoes use selenium instead of sulfur? It was a great, brilliantly conceived project. But I went away for the weekend to the beach, and when I got back, all the tomato plants had died, so it was kind of not really a success. But I had already submitted my project, and indeed, it turned out to be one of the top 40. 2 of us at the Bronx High School, Gary Feinberg and myself, were selected to be the top 40. We were numbers 39 and 40, as it turns out. We went to Washington to spend the weekend, my first weekend away from the parents in a foreign city, Washington, D.C. And I had to have some demonstrations. And so the few months after I heard that I won this thing and I was going to Washington, I hurriedly synthesized, at great danger, all these different chemicals, selenium oxychloride, selenium bromide, things that you don't want to touch. I mean, they're dangerous, unpleasant things. I had a liter of bromine in my basement. Now, no sane person has a liter of bromine in their basement, and my parents didn't know and didn't care. Whatever. Thank God I didn't destroy the home or kill us all. So that's my exposure to selenium halides. That is to say, bromides, chlorides, and iodides, and things like that. Why did this synthesis of selenium halide interest you? I went down to the 42nd Street Library, the big, the New York Public Library, and got these ancient 19th century books on chemistry, which were like cookbooks. They told you how to synthesize different things, and I copied out the technique to create selenium tetranitride, and by God, I succeeded. How does electroweak theory, this is also from Sam, relate to the evolution of the early universe? Now that's harder to explain. Electroweak theory is this thing that Steve Weinberg and I and Abdus Salam was the first Muslim to win a Nobel Prize in science. But when he won the prize, he announced to Time magazine how proud he was to be the first Muslim to win the Nobel Prize, and which is not true. So Steve Weinberg and I sent him a telegram and said, "Congratulations, Abdus." He was our friend, we knew him. I didn't know that Sadat had converted, because Sadat, the president of Egypt, was indeed the first Muslim Nobel Prize winners. And by the way, there have been other Nobel laureates Muslim Nobel laureates in science after Abdus. Anyway, how you see, I can't answer that question. You have to take another course. I'm sorry, Sam, that's too hard. What are you currently working on? Well, I'm currently trying to figure out what to tell you guys, but I'm not. It's a very delicate situation now, because the standard model, which is our people in my field's view of the universe as of 1970s or so, has been extraordinarily successful, and it's a wonderful theory of almost everything but gravity, and it works terribly well, except there was one missing ingredient, one particle that was part of the theory. It was in fact the particle that was first introduced into the theory by my classmate Stephen Weinberg, and it was finally found in this last year, we think. And the trouble is that having found that, a number of other possibilities have been excluded, and we really don't know how to make a better theory yet. And so the situation right now is very puzzling. We need some help, possibly from some of you who might become physicists. Maybe you can supply some of the answers. I can't. What am I correct? Okay. What does it take to become a physicist? Well, I think the right answer is that, let me change the question. It's what do you need to become, what does it take to become a scientist? It takes a love and a fascination for science. What does it take to become a physicist? A love and a fascination for physics. Except to become a really good physicist, you have to have a love and a fascination for mathematics as well. Next question. Physics is often described as the hardest science. What can approach science to understand the subject? The question doesn't make a great deal of sense the way it's been transcribed.
I'm sorry, Dr. Glashow, that's my fault.
No, it's okay, but I understand what the question is asking, and the answer is that if you want to be a great chemist, you better learn physics. If you want to be a great biologist, you got to learn physics. If you want to be a great archaeologist, you probably don't have to learn physics. But physics is extremely useful, especially to science. Okay, what is the charmed quark in simple terms? That's from Amanda. Well, it's the charmed quark, actually, that I prefer. not the charming quark. I invented that name. It's my one claim to humanoid fame is that that word is credited to me by the Oxford English Dictionary. Yes, I invented the word charm to describe the fourth quark, and what it is just another quark. But what does that mean? Back in 1964, Murray Gell-Mann, my second mentor that I mentioned before, invented the idea of quarks, invented the word quark to describe these things, and he had just 3 of them. And in that same year, I realized that it would be neat if there were a fourth quark that would make things sort of more symmetrical and more beautiful. But I really didn't have any good reason for the fourth quark until a few years later, in 1970, me, together with an Italian guy and Luciano Maiani, and a Greek guy, John Iliopoulos, we saw that the charmed quark is actually necessary if you wanted to have a unified theory of weak electromagnetic interactions. It was an essential ingredient. So that was an important idea, I think, that we had, that eventually was recognized as another of the keys to allow the creation of the Standard Model. So it's my favorite quark. There are now 6 quarks, but I have a kind of parietal interest in the charm quark because me and my friends were the people who suggested its existence. What is a charm quark? What made you decide to go to Harvard? Well, yeah, I was turned down, but I did go as a graduate student. And why did I go to Harvard as a graduate student? Because I wanted to study with this person, Julian Schwinger, that I succeeded in studying with, even though he was a kind of difficult guy. He wasn't around very much. You had to catch him, like catching animals or trapping rabbits. You had to design a technique. He would lecture at the blackboard perfectly in a radio announcer's voice, and his equations, which he would write down very rapidly, would end at the last blackboard at the moment that the class ended, and he would slip out the door and disappear. So the one technology was to sit in the back of the room and leave the lecture toward the end and go down to the bottom of the staircase, where he would have to pass on his way to lunch, and trap him. Eventually, I got to know him better, and we'd have lunch together. Anyway, were you interested in physics as a child? No, I was interested in comic books as a child. My introduction to literature was comic books, and I graduated from comic books at the age of 11 or 12 to science fiction, thrilling wonder stories and astounding science fiction. And I know I was only 11 or 12 because I still have those science fiction magazines, which I hope someone would buy and decide it, but these days it's hard to find a market for old science fiction magazines. So I was reading science fiction, and I learned a lot of science out of science fiction. Are other people in your family scientists? No, not a one. My father was a plumber, my mother was at home, my brother was a dentist and a doctor. I was expected to be a dentist or a doctor too, but I faked them out, became a professor. My parents were not too happy until I started winning scholarships and awards and things, and they were a little bit happier, but I think they would have rather that I be a doctor. No, I had 4 children, and they have 4 spouses, and none of those 8 is a scientist. And they have a total of 9 grandchildren I have, but we don't know if they're going to be scientists because they're kind of little. We'll see. I'm not aware of any other one. No, there was one person who was born, a second cousin once removed, who is a physicist. And he has the same name, Sheldon Lee, that I have because he was born the week after I was born. He's a physicist. Not a very good physicist. How did you know what you wanted to study? I don't know. I That's a question I can't answer. How did you like California? Hey, California is weird. I mean, I spent 7 years to 5 years in exile in California, and I sort of kissed the ground when I got back to Massachusetts. It's kind of strange, California. The weather is real good, but some things are, we'll get into that another time. Did I have a pet? Oh, I had 2 pets. Taffy got run over when I was about 12. We got a dog around 1973 or so. I had a terrible name. If I tell you the name, I'll be very embarrassed, but I'll tell you. We gave him 2 names. Pini Testicopoulos. Cute little dog. And he died soon. He was run over by a car too eventually. And now my eldest grandson and his siblings have a little dog called Ringo, who's cute and lovable, and they have an electric fence around their house, so he's not going to get run over. 14. I don't know how much time we have, but I'm up to 14. If you didn't go into research, what would have been your second career choice? Frankly, I would be researching something else. I don't think I have the stamina to have a 9-to-5 job of any kind. I can't imagine. Maybe I could be a high school teacher, possibly. That's the only thing I could think of offhand. Because it's not just that I'm a researcher, I'm a teacher, and I spend at least half of my effort teaching. Right now I'm teaching 12, a very small class limited to 12 freshmen in the honors program at Boston University, the Kilochan Honors Program, which is a new concept at BU. And I'm teaching them about energy. It's a course on global warming, climate change, alternative energy, wind, solar, nuclear, all that stuff. With 12 bright kids, it's really a privilege to have such a course. How did you miss the discovery of the Gelman-Okubo mass formula from David Menjival? Well, that's a brilliant question, actually. I'd love to spend some time on that. It's some technical thing, okay? The Gelman-Okubo mass formula, it's called the Gelman-Okubo mass formula because it was invented by Gelman and Okubo. And I was working on that with my buddy, late lamented Sidney Coleman, who was kind of unofficial graduate student of mine. And we came really close, but I asked him the key mathematical question, and for once in his life, he got it wrong. And so we missed that discovery. And I'm sad about that. We should have discovered it. It should have been the Coleman-Glashow formula. There is a Coleman-Glashow formula that has something, but I'm not going to get into that. But yeah, I'm sorry about that one. It's a good question. How good were you in calculus? Okay, that's a really good question. Because when you study in the conventional way quantum mechanics, and you learn quantum mechanics in college, you solve the problem of the hydrogen atom, which has been one of the first big problems to be solved. And the way it's usually solved, doesn't have to be, but usually, is you separate it out in terms of what's called a radial problem and an angular problem. And the radial problem you solve with calculus, and the angular problem you solve with algebra. And I found the algebraic stuff neat, and the calculus part sort of trying. And I much preferred the kind of radial things. And so my career has been more or less staying away from things involving calculus and focusing on things involving algebra, simple algebraic concepts, which have been enormously useful. And so I spent most of my time playing with 2x2, 3x3, 5x5 matrices, which are simple algebraic things. So that's a good question. how good we are. Other than its lack of experimental data, why are you skeptical of superstring theory? Well, I am skeptical of superstring theory because it is impossible to prove wrong. That is to say, on this, string theorists will basically agree with me. At present, there is no conceivable experiment that could be done to prove that superstring theory, or sometimes just called string theory, is false. And yet there are many, many of the best and brightest scientists, physicists, are working on string theory, but they are not making any predictions, and there's no way we can do an experiment or make an observation that can prove string theory to be wrong. And that reminds me of when I went to college. They made me take other courses than physics, of course, and we learned about medieval theology, where people argue about how many angels can dance on the head of a pin. And many, many of the best and the brightest scholars in medieval times worried about this question. But there was no way they could tell. We still don't know. So that's my take on string theory, which is different from some people's take. Okay, next question. Have you studied other phenomena such as black holes? Yes. I'm not going to go into that. I've studied all phenomena in principle, and all kinds of different phenomena. What is your favorite sport? Not quite sure. Billiards, I think. I have a 19th century billiard table upstairs. I'm not very good at it. I learned to play in college, not so much as a sport, but to supplement my scholarship. Bill, I expect to win the Nobel Prize for my work. I certainly did not expect to win the prize for someone else's work. But no, I did not. And it's important to say this. There's been a bit of, maybe Ed has emphasized the brilliance of Nobel Prize winners a little bit too much, because there are, in fact, many, many extremely talented scientists, many of them more talented than I by far, who did not win the Nobel Prize and who will not win the Nobel Prize. There are only a few hundred Nobel laureates. In physics, there are only somewhere between 1 and 3 new ones each year, and there are a lot of people who get left out who deserve that. So we shouldn't have this focus that you've got to win a Nobel Prize. People who just devote themselves to win Nobel Prizes are not thereby increasing their likelihood to win a Nobel Prize. Basically, if you're going to be a scientist, be a good scientist. And if you happen to be very lucky and to have the right ideas at the right time, then you might win the Nobel Prize, but you might not. So it's not something you should focus on. And there are a lot of people out there who devote themselves exclusively to trying to win the Nobel Prize. Some of them are great scientists, but they're making themselves sick, worrying each year, is it going to be me? Is it going to be me? Well, actually, there was one year when I really thought it was going to be me. And so at 6 o'clock in the morning when the telephone rang, I thought, oh my God, that's the Swedes. They usually do that. I answered the telephone, and no, it was our au pair girl who was actually calling a taxi, and she dialed us by mistake. She was very apologetic. We're still friends with her. We took her to Stockholm when I won the Nobel Prize, and we had dinner with her last night. So we've forgiven her. A year later, on the same day, wasn't the Swedes. It was WEEI saying, what are you going, Professor Glashow said, yes, what are you going to do with the money? Excuse me, what money? I said. You just won the Nobel Prize. And so I heard from WEEI, followed by other radio stations. A week later, I finally got a message from the Swedes that I had won the Nobel Prize. But it was true, and WEEI had it right. Do you know who nominated me for the Nobel Prize? As a matter of fact, I know. You're not supposed to know, but I've been told that it was my second mentor, Murray Gell-Mann, who was one of the people. I may have been nominated by several people, but one of them was Murray Gell-Mann, who was the reason I went to Caltech after I left Europe. What is the coolest thing you've ever done in my life? Oh, that was skiing in New England, for sure. Because you lose a glove and you've lost a hand. It's cold in New England. I know that's not what the question meant. Who are some of the important people behind my success? And there I would have to say, aside from people like Julian Schwinger, aside from my parents and my two brothers, I would mention the teacher I had in 7th grade, because they were telling me about how the sun goes around the earth and the moon goes around the earth, and the earth goes around the sun. I got it right this time. And I noticed that the earth turns around its own axis much more rapidly. It rotates much more rapidly than it revolves around the sun. But the moon doesn't, because the moon always shows the same face to the earth, which I realized meant that its period of revolution is the same as today, so that it always faces us. And I asked the teacher why this is, and she